For decades, the Apollo moon program waited in silence as an unfinished human ambition. Now the rockets are roaring again because engineers are no longer just planning a landing, but streets, factories, and permanent life. Inside the frozen polar craters of the moon lies a resource that can transform exploration into a civilization. This time, it is not just about a flag. It is about supply chains, energy, and survival systems. Everything needed to live where a single cracked seal, a single power failure, or one delayed launch can instantly end a mission. In October 2009, NASA launched the LCROSS mission to answer a long-standing question. Does the moon contain water in significant quantities? Instead of a soft landing, scientists intentionally guided a spent rocket stage into a collision with the permanently shadowed Cabeus crater near the South Pole. The impact ejected a plume of lunar dust and vapor over the crater's rim. The following spacecraft flew through this plume and analyzed it before it settled back down. The results exceeded expectations. Spectrometers revealed water ice mixed with regolith, and measurements showed approximately 5% water by weight in the recovered material. Even more surprising was that the plume also contained other volatile substances, carbon dioxide, sulfur molecules, and traces of other useful compounds. Water can be purified for drinking, split into hydrogen and oxygen for breathable air, or converted into rocket fuel. A base capable of mining ice reduces dependence on launches from Earth for its survival. Engineers began planning survival in conditions without breathable air, a protective atmosphere, and stable temperatures. Lunar soil, regolith, contains silicates and minerals that can be melted or sintered using concentrated sunlight or microwave energy. NASA and the European Space Agency have already tested ways to turn this dust into bricks, structural panels, and protective barriers. Radiation is another serious obstacle because the moon lacks a protective atmosphere or magnetic field like Earth. One of the most studied solutions is surprisingly simple: burying habitat modules. A few meters of regolith can protect against solar radiation and micrometeorites. Inside the protected structures, closed systems will recycle water and oxygen, and hydroponic farms will provide fresh food and reduce the need for supply from Earth. Over time, the base can transform into a full-fledged settlement, laboratories, industrial zones, and residential neighborhoods connected by hermetic tunnels. The first lunar city will not be a glass skyscraper. It will be underground, engineered environments designed primarily for survival, then for comfort, and always for further development. A lunar base that mines ice and produces fuel will be able to supply ships heading further into the solar system without fully relying on launches from Earth. In such a scenario, the moon becomes something more than just a settlement. It changes into a transport hub. But despite advanced rockets and available resources, permanent life on the moon encounters biological problems that technology cannot completely eliminate. Long-term exposure to ubiquitous radiation increases the risk of cancer, damages DNA, and threatens the electronics that maintain life in hermetic modules. Low gravity is another factor. Astronauts on the International Space Station lose bone density and muscle mass. The gravity on the moon is indeed stronger than orbital weightlessness, but it still amounts to only about 1/6 of that on Earth. Elon Musk proposes a completely different path. SpaceX has apparently truly shifted its attention to building a self-growing city on the moon. The reason for this turnaround is relatively simple. Building a lunar base is possible within approximately a decade. It will be very difficult, but it does not seem impossible. In contrast, building a full-fledged city on Mars would require at least 20 years and probably even more, if it is realistic at all. Elon himself has spoken about this repeatedly, with almost no softening. We know that if a person gets sick or injured on the moon, they can be returned back home. What does a self-growing city on the moon actually mean? This formulation gives a fairly clear hint as to where all this is heading: artificial intelligence, automation, and robots. And it is apparently no coincidence that SpaceX recently bought an entire AI company. Moreover, one that also belongs to Elon Musk. The company xAI also owns the social platform X and is most known for its multifunctional language model, Grok. It is precisely through xAI that a bit more concrete information has appeared about what Elon wants to build on the moon. In the first place, satellites. SpaceX plans to create a factory on the surface of the moon for manufacturing satellites with artificial intelligence and an electromagnetic catapult that will launch them into orbit. The lunar plant is to manufacture.